What if your Arduino could measure the environment around it, not just detect signals, but actually understand the air in a room? That is exactly what we are going to do today. In this lesson, you'll learn how the DHT11 sensor works, what is happening inside it at the physical level, and how to use it to build a simple weather station that displays real-time measurements on an LCD screen. If you're new here, welcome. This is lesson 20 of my 24-part series called Arduino for Beginners, where you'll actually understand how Arduino works instead of just copying code. That said, let's start by looking inside the sensor. Inside the DHT11, there are two sensing elements and a small processing chip that turns physical measurements into digital data your Arduino can read. First, humidity. The DHT11 measures relative humidity using a capacitive sensing element. Inside the sensor, two electrodes are separated by a moisture-sensitive polymer layer. When the surrounding air becomes more humid, this material absorbs water vapor. As the moisture level inside the polymer increases, its dielectric constant shifts, meaning its ability to store electrical charge is altered. This directly affects the capacitance between the two electrodes. More humidity leads to greater moisture absorption, which produces a measurable capacitance variation. The internal circuitry detects this electrical variation and converts it into a relative humidity reading that your Arduino can understand. Now let's talk about temperature. The DHT11 uses a NTC thermistor, which stands for a negative temperature coefficient thermistor. This is a resistor whose resistance decreases as temperature increases. Inside the sensor, this thermistor is part of an electronic measurement circuit. The sensor measures its resistance, converts that into a temperature value using calibration data, and outputs the result digitally. So instead of tracking changes over time, it directly measures the current temperature at each reading. Finally, a built-in chip handles everything. It reads the humidity and temperature signals, converts them from analog to digital values, applies factory calibration, and sends a formatted digital signal to your Arduino through a single data pin. This is why the DHT11 is easy to use. The complex signal processing happens inside the sensor. In terms of specifications, the DHT11 measures temperature from 0 to 50 degrees Celsius with about 2 degrees Celsius accuracy, humidity from 20 to 80% with about 5% accuracy. It's not a precision instrument, but is affordable, reliable for learning, and perfect for beginner environment sensing projects. Additionally, the pinout is also simple: VCC to power, GND to ground, data to digital communication with the microcontroller. One important limitation: the sensor can provide a new measurement about once per second. In our project, we read it every 5 seconds for a stable update on the display. Now that you understand how this sensor works, let's use it in a real project. Before moving on, a quick thank you to today's sponsor, GF Robot. If you don't know them yet, GF Robot is one of the top global providers of open source hardware. For this series, they provided the Mind Plus Arduino coding kit, a collection of sensors, modules, and accessories designed specifically for learning electronics step by step. If you want to follow this course more easily, using a kit like this makes the process much smoother because all the components are designed to work together. You can find the link to GF Robot's online store in the description below. Thank you again to GF Robot for supporting this series and helping make STEAM education more accessible for everyone. Now let's build the project. Today we are building a simple weather station. The DHT11 will measure temperature and humidity, and will display the readings on an I2C LCD screen. For this project, you need Arduino Uno, input-output expansion shield, DHT11 sensor, I2C LCD module, and a few jump wires. Start by attaching the expansion shield to your Arduino. Next, connect the DHT11 module to digital port 2 on the shield. This matches the pin defined in the code. Now, connect the LCD display SCL to A5, SGA to A4, VCC to power, and GND to ground. Once everything is connected, go to the GitHub repository of this series. The link is in the description below. Open the folder for lesson 20 and download the project code. Now open the sketch in the Arduino IDE. But before uploading, make sure you have installed the libraries Adafruit DHT sensor and GFRobot RGB LCD 1602. After that, upload the code and watch the display. You will see temperature in Celsius on the first line and relative humidity on the second line. The system updates every 5 seconds, even though the sensor itself can measure once per second. This slower update rate improves readability and stability. Now let's move on and understand what the code is doing behind the scenes. We start by including the required libraries, as well as defining variables, constants, and objects. Then, in the setup function, we initialize the communication with the LCD module, the DHT11 sensor, and the serial monitor. In the loop function, the program checks whether 5 seconds have passed. If so, it reads humidity and temperature from the sensor. The code also checks for reading errors. If the sensor fails to return valid data, the system prints an error message on the LCD and serial monitor. On the other hand, when readings are successful, the Arduino prints detailed values to the serial monitor, displays temperature and humidity on the LCD, and formats the output for clarity. This structure separates sensing, validation, and display output, a design pattern we will reuse in future projects. If you are enjoying this series and want to take your skills further, I have an announcement. I'm preparing a masterclass about building drones using Arduino and other techniques like 3D printing and PCB design. This is a natural next step once you understand how to collect and interpret real-world data and have mastered the Arduino fundamentals. If you are interested in that, I've created a waiting list. You can find the link in the description below. By joining the waiting list, I guarantee you'll be the first to know when this masterclass is available. And that's it for today's lesson. You learned how the DHT11 measures humidity and temperature and how to build a simple weather station that displays real-time data. At this point, you are not just wiring sensors but understanding how they can be used to interpret the physical world. If you enjoyed this lesson, subscribe so you don't miss the next one. And before you go, check out the video appearing on your screen as it will help you improve your maker skills. Thanks for watching and I'll see you in the next lesson.